I didn't know.
So I just put like 4 in there.
Well, I did like the a squared plus b squared equals c squared thing, and I got every single one, like, cause you know how like your a squared plus b squared equals the c squared. So I did every single one, but none of them really equaled it. I just put which one was less than it.
All right, notes from last time. I'm going to run back through these real quick. And again, I'm going to post this online, so if you have any peers that are in my orange days, you could tell them, go back and look at this, and I'm going to also post some of the problems that we do so that you can help to see for the park test tomorrow. This is stuff we took last time. Just have out the notes from last time. We'll probably add some stuff to it. Hopefully with Pythagorean's theorem, again, just remember a squared plus b squared equals c squared. You know, a and b are the legs, and c is the hypotenuse. You're going to use Pythagorean's theorem when you know two sides and you're looking for the third side. So if ever you know two sides and you're looking for the third side, that's when you're using Pythagorean's theorem. Sharice, I'm probably going to go too fast, so get down what you can, and then get the rest of it off somebody else, or get online and get it or something, all right? Please remember, every single thing that we do today, all this stuff that we're doing, and Sydney's going to make sure that she's watching closely on some of it, because the very first thing you got to do with all these triangles is label them. You got to somehow label them, every single one. This one, the only thing I would label every time is the hypotenuse. Marking that hypotenuse, knowing where the hypotenuse is, if you're using Pythagorean's theorem. Does that make sense? You always got to know which side that is so you know to put it right there. And what do we know about the hypotenuse all the time? It's always the longest. If it doesn't come out to be the biggest when you get an answer, then you messed up somewhere. Remember these? I call them families. They're actually called Pythagorean triples. And if you see a triangle that fits one of these, then you don't have to do all the work. So if you see a triangle that's got one leg that's 3, one leg that's 4, what can you write in on that side? You can write 5 in there, and you don't even have to use Pythagorean's theorem. All these are sets of numbers that fit Pythagorean's theorem. Now the bad thing is, and I didn't even bother to mention this in my other classes because I just figured it'd confuse them. If I put that on there, is that side over there going to be 4? No, it doesn't work that way. That longest side has to go with. And I do remember at one point on the OGT test seeing they stuck something like this on there, and I thought, crap. That's just great, because of course everybody over here was going to put 4, and it was going to be wrong.
It has to be bigger.
And that's, you have to make sure that you look at it. These 3 right here are the 3 that we use more than any other. And if you remember, it can not just be those, but any multiple of those. So if you see some triangle, it's got a side 500, another side 1200. Anybody tell me how long that hypotenuse is going to be? 1300. That'd be nice if you could pick that out, right? Instead of trying to set up Pythagorean's theorem for those great big huge numbers. So if you could see that, it'd be real helpful, any of those. Ones that fit here again, you know, like 6, 8, 10, sort of go with that family. 30, 40, 50, so on, so on, so on, all those. Just multiples of those sets of numbers. The 45, 45, 90, and the 30, 60, 90 special right triangles. First, the 45, 45, 90. Soon as you see that you have a triangle that's got a right angle in it and one of the angles is 45, what's that tell you about the other angle? It's got to be 45. This is also called, again, an isosceles right triangle. If we didn't write that down last time, it's also called an isosceles right triangle. The very first thing I want you to do every single time you see a 45, 45, 90 triangle, draw in these arrows and label the sides. The side across from the 45-degree angle Most books will label it X. I always use L just to be have a different variable. Side across from the other 45, label it L. Side across from the right angle is L radical 2. And this is where most of you are getting confused at. Because as soon as you see that radical, what do you want to grab? Your calculator. No reason to. Leave it that way. Right? So if I give you a triangle and it looks like this, and it's a 45, 45, 90, and I tell you this side over here is 7, that's L. That should be labeled L. That should be labeled L radical 2. We know that L equals what? 7. So wherever we see L, we stick 7 in its place. How long is this side going to be then? How long is this side going to be? 7 times the square root of 2, and you just leave it that way. All right? A lot of stuff that you do from here on out in math, you'll just leave in that radical form. Radical form is just another way to write a number. So just like you wrote in the past, you had 1/2 and you wrote that as 0.5, and other ways you might have also written that as 50%, and those three all stood for the same number. This is just another form, another number form to write stuff in.
It's okay to solve it, like, I solved it, like, solve the hypothesis.
Yeah, I did too.
What do you mean?
Well, like, if you would have put
Number
the
50.
L radical 2, if you actually would have typed that into your calculator.
I'd rather you
solved
just
it.
left it like that.
Well, but would you get like points counted off
Yeah, probably.
from the state?
Yeah, probably. Because if they ask you if it's a multiple choice question,
Well, yeah.
that's probably the form they're going to give it to you.
If it's not a multiple choice question, they like.
Maybe,
consider it.
because if they want an exact answer, that right there is an exact answer, and the answer you're given is no longer exact because you rounded it off.
Because now, all the things on the homework, if it had to do with that,
I probably wouldn't be a real stickler about it right now because
Yeah, we
the
just
way
don't
we're
like
going
it.
over it. But you need to start understanding that that's a fine form. That's a whole lot better form than the decimal answer you're giving anybody.
What about?
No, and the second thing is, if you know this already, is it taking more work to grab your calculator and figure it out?
Yeah.
So why do it if I'm telling you you don't need to? You're just doing more work. Why?
And then also if you were to find like, the longer side, since you would do the variable or whatever the
We're
number is.
gonna do some of those.
Time, would you leave that in the same form?
Right, we're gonna talk, I'll try to do one of those here in a minute. All right. Next one, 30, 60, 90. Again, write any of this down if you haven't got it written down. Maybe on your notes, you might have to write this in. Some reason my radical 3 there disappeared. I don't know where it went to. So check your notes and make sure. I don't need to take that, do I, Olivia? Don't say what, because that makes me nervous. So make sure you're writing this down. In a 30, 60, 90, the very first thing I want you to do every single time, side across from the 30-degree angle, label it L. Side across from the 60-degree angle, L times the square root of 3. Side across from the right angle, 2L. So all these, you got to figure out, hey, what am I using here? Am I using Pythagorean theorem? Am I using the 45, 45, 90 stuff? Am I using the 30, 60, 90? Am I using the trig functions, the SOHCAHTOA stuff? And then once you figure that out, then you label your triangle accordingly.
Yes.
That's the key thing to all of it, labeling the triangle to start off.
Question. Okay, so we're on our like geometry part test. Why are they giving us trigonometry stuff?
Because it's part of geometry.
Yeah, I had,
Well, then
like,
why isn't it
Yeah,
geometry?
everyone's saying they had a bunch of questions on. I had like
If it's-
one. I'd rather have the
I think
geometry.
I
I had a
was-
bunch.
Oh, I wasn't done that with that.
Mine were all on trigonometry.
I had to go starting
Why am I not
on
trigonometry?
Everything.
Here.
That's what I had every time.
Mine
Mine
was
was
on
told you I was
on
gonna get quick.
trigonometry.
All right, the trig ratios. With the trig ratios, again, go back over it. What somebody figured out a long time ago. if we have a right triangle and one of the angles is 25 degrees, then that right triangle with a 25-degree angle is similar to every other right triangle with a 25-degree angle in it in the whole world, right? So instead of all the stuff that we've been doing this every time, needing two triangles and setting up a proportion, right? Instead of doing that every time, somebody figured out, hey, you know what? We don't really need two triangles every time because we know how these are going to be related to each other every time. And so they went through and they made out this chart and they said, all right, in a triangle that's got a 90-degree angle and a 25-degree angle, this side compared to this side is always going to be this decimal. And that's where all these decimals come from. So they've taken this first ratio and they've made it into a decimal for you. So this is like your first triangle. And you don't even need the first triangle anymore because you got this or you got your calculator that's got all of them already programmed in there. And all we need to do is set up the second ratio. Does that make sense? So instead of having two triangles, instead of having this triangle and saying they're similar, we no longer need this triangle because it's all right here on this paper or it's programmed into your calculators. All we need are the parts of this triangle. And then we can do our proportion. And that's what we're doing every time we set up sine, cosine, or tangent is we're setting up a proportion. S again stands for sine, C stands for cosine, T stands for tangent. And I'm going to write these real short this time. This is the sine. What's the O stand for?
Opposite leg.
Opposite leg. And I'm just going to put opposite. And this is over the hypotenuse. So that's telling you the sine ratio is the opposite leg over opposite leg on top, hypotenuse on bottom.
Adjacent leg.
Adjacent leg
Over hypotenuse.
over hypotenuse. And then this one is
Opposite over adjacent.
opposite over adjacent. So those are your three trig ratios. It's not hard, Sharice. Don't even give me that look. I'll call Corbin in here.
He will not help me. I have like two problems at all.
He seems like he's a little meaner this year than he was in the past, is he? Is he meaner all of a sudden?
He's got a girlfriend.
Is that what it is? Too big a man for everybody now?
I have asked him so many times to help me have this people.
Like they have
He
like
came
a
into my
triangle.
class last year, he was always smiling and
Which ones
everything.
match up with
I'll never
what?
see him with a smile on his face now.
And then which ones match up with which?
Him and Courtney
And
fight?
you have to like do a whole
No.
stuff.
Oh, actually, I just saw another night.
All right, this is the same thing right here, except you might want to write this. You got to put an angle in there. I didn't put an angle in there, so if our angle was X that we were looking at, and I might have skipped over this one last time, so I'm not sure. The sine of whatever angle you're dealing with, opposite over hypotenuse. The cosine, adjacent over hypotenuse. The tangent's opposite over adjacent. Every single time you're setting up an equation. When I set up a proportion, is that also an equation? Is a proportion an equation? A kind of equation?
Kind of.
Yeah, it is. Anything that's got an equal sign in it is an equation. All right? So these are all, they're actually proportions, and what we're going to do is we're actually going to put a 1 underneath each one of those to make them out to be proportions as we solve them. But they're still equations. All right?
What if we were to download programs on our calculator? Would we be allowed to do that?
Yeah.
Okay, well, my sister was helping me with my homework last night, and she didn't care to like teach me how to do it really, and so I had a program like it was what is it? It's like I messed it up this, now I can't use it. I don't know how I messed it up. It was sine 2 angle, and so that was actually really helping me on the homework.
Yeah, some of them might
But
work.
I messed it up somehow, and I can't use it. I don't know what.
You got to be careful with those because a lot of them aren't set up for what we're doing. A lot of them are set up for,
Well, and then
Stuff that's
today,
going on
when I
to
was
the next
actually looking at my notes, I realized they were all like 30, 60, 90, or 45, 45, 90, so then I was like, oh, I missed my notes, I gotta do that.
all right. This I do want you to write down. I know we didn't write this down last time, so copy this triangle. And we're gonna write down a couple of things with it, and I'm gonna try to explain some stuff. I don't know if this was on the first part of the test or second part of the test, and I probably shouldn't be recording this, but my son's already taken the park test, the math part. And I can't remember if it was the first part or second part that he's talking about. But I know one of the problems on there was a real easy problem, and if you listen today, you'll be able to answer it. All right, so focus on what I'm going to tell you, because it was like the easiest one on there, and he's having the same trouble that you guys are having, because they haven't gotten to all this stuff either. All right, so, and he's supposed to be in an advanced geometry class. They're supposed to be moving a lot quicker. Not working out. So on this triangle, first thing I'm going to do, I pick an angle that I want to deal with. Sydney, you with me?
Oh, yeah.
Put that down, put it away, get the notes out.
They are out. They are.
And write on them.
I am. See?
Are you drawing this picture?
Go on. Come around.
No, it's not.
Yeah, it is.
And write this stuff down. Sydney, why am I arguing with you? I'm trying to help you out here and you're not doing what needs to be done. So then follow along. So we got angle A here. That's the angle we want to deal with. The very first thing, if you know you're dealing with SOHCAHTOA, sine, cosine, tangent, first thing you got to do, label the triangle. This side is going to be called the opposite leg. And I'm just going to write opposite. You don't have to write out leg. All right? The side across from the right angle is always called the what? The hypotenuse. The adjacent leg is the one that's left over. That's the one that everybody has trouble with. What's adjacent mean again? Anybody remember that?
No. Shares a side.
It shares the side. It's hooked to it is what it actually
We
means.
did do this.
So this is the adjacent. All right? That's your adjacent leg. Every single time, figure out which angle you're going to deal with. Label opposite, adjacent, hypotenuse. Every single time. All right? Now what we're going to do here, we're going to find the sine of angle A, and I want you to write this down.
That's what I was asking about.
We're going to find the cosine of angle A, and we're going to find the tangent of angle A. Now normally, there'll be numbers and everything else given on these triangles, right? Since we don't have any numbers on this triangle, I'm going to show you like the generic form of it. Across the side across from big A, guess what it is?
Big.
Little a.
Little A.
Side across from big B, guess what it is?
Little B.
Little b. Side across from big C is little c. Look at what we have now. A, B, and C. Guess where Pythagorean's theorem came from? A squared plus b squared equals the hypotenuse, which is c squared. That's like the generic triangle for any right triangle. That's the one that sort of fits what we normally do, everything. All right? So all we're going to do, if we're looking for the sine of angle A, sine is the so part. So what two things does it deal with? Opposite over hypotenuse. Well, what's the opposite side this time for angle A? Little a. So we put little a on top. What's the hypotenuse? That ratio right there is our sine ratio, A over C. Again, there's going to be numbers in there probably on most problems, right? But for what we're doing right now, just setting them up, that's what you do. Cosine.
I had one that was letters.
And that's why I'm showing it. So
I think I got it right. It was actually very weird.
next one, the cosine. What's cosine? That's the co part. Adjacent over hypotenuse. What's the adjacent? B over C. The tangent. That's the TOA part. What's it deal with? So what's that going to be? A over B.
So,
Those are just our ratios. Now, we're not really doing anything with them right now, but at some point, we're gonna know some of these numbers, and we won't know some of them, and we'll be able to stick in stuff here and be able to figure out the part that we're missing. And I'm gonna show you that here in a minute, all right? But the other thing I wanna go over, what if we don't like angle A? I like angle B a whole lot better than I like angle A. Is all that gonna work? No, we need to switch everything. So give me a second. I'm going to try to erase some of this, some of this, some of that. Gotta erase that, gotta erase that. I'm gonna leave the B, A, and C because that's still gonna be the same. All right? Now, watch what I do here. If we want to deal with angle B instead of angle A, now I label this triangle. What's this side going to be labeled?
Opposite.
That's the opposite leg. What's that side going to be labeled? I didn't really need to erase that, did I? Then this side down here, the one that's actually, the leg that's actually hooked to angle B is now the adjacent. How did that switch? What changed? The opposite and the adjacent switch places. That's all that's going to change on these two acute angles in this same right triangle. They just switch places when you're dealing with a different angle. So now let's look at this. Let's find the sine of angle B, cosine of angle B, tangent of angle B. Let's write these down because I'm telling you it's going to make a big difference. It's going to make more sense to you.
little b over c.
So it's opposite, for sine, it's opposite over hypotenuse, right? So B over C, Sydney said. A over C. Now, before we go any farther, have we seen either of those two ratios anywhere before? They were up here, weren't they? Every single time when you switch from one angle to the other in a right triangle, you're never ever going to be dealing with a 90-degree angle. It's got to be one of the acute angles that you're dealing with every single time. All right? Can't be the right angle. Every single time. The sine of one of the angles is going to be the cosine of the other. The cosine of one of the angles is going to be the sine of the other. So one of the problems on the park test that my son told me about, and again, hopefully this doesn't get out, one of the questions on the park test that he told me about was, Dad, they gave me this picture and it looked something like this, didn't have any numbers on it, but they said the sine of angle A equals, and then they just listed a bunch of stuff. Well, the sine of angle A
Oh, yeah.
is going to equal what?
I had that.
The cosine of
Yeah, you
angle
gotta
B.
like pull the blocks down into them.
I wish we could use like.
Remember that failed it?
So does that make sense to everybody? All right? Now, let's look at the tangents. What's the tangent of angle B? A, say it again.
A over c. Wait, b over.
Opposite over
Oh, a b over a.
B over A. So now look at this. Shh. What do you notice about the two tangents? What's that called in math? Not called flipping it. They're reciprocals of each other. The tangents of those two are always going to be reciprocals of each other. The other thing I want you to write down, because I know I seen one of these on the practice test. Sine and cosine. If you could read that. Everybody knows that says cosine, right?
Yeah.
Are less than one. They always have to be less than one. So your decimal, so if you come up with something and it says, you figure out the sign of something and it says 1.2, something's wrong. So it's always got to be, if you're punching in the calculator or whatever, it's always going to look something like that. point something, 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 something. Can't be a number out in front. It's always got to be less than 1. The other thing, tangent can be anything. The tangent can be anything. So the tangent might be 0.7258. It might be 37.9362. Sine and cosine always have to be less than 1. Tangent could be whatever. Anybody tell me why the sine and cosine always have to be less than 1? Look at your ratios here. What do you know about that C every single time?
It's the hypotenuse.
It's the hypotenuse. And what do you know about the hypotenuse in every right triangle? It's got to be the longest side. So whatever you put in here and whatever you put in here, B's always got to be smaller than C. A's always got to be smaller than C. So if you come up with a sign that's bigger than 1, you put the sides in there wrong somehow. Because that hypotenuse always has to be the longest. Does that make sense? It's always got to be that way. And for everything that we're doing right now, all these are always going to be positive. Notice on the chart that I gave you, if we look, first of all, if we look down through sine, the only one that's more than 1 or 1 or more is 90 degrees. And what I just tell you, are we ever going to use that one? We're not going to deal with the 90-degree angle. We're always going to be dealing with one of the other 2 angles. All right? So all those numbers are less than 1, but then when you look over at the tangent, it goes way up to like 57. So it could be anything. And then you notice this down here for 90, it gives you this little symbol. Anybody know what that little symbol is?
Infinity.
Infinity. It means it could go up to anything. All right? But then the other thing is, they're all positives. We're not dealing with any negatives for the moment. Now we will, and when we get to the other parts, I think you guys are intelligent enough, when we get to the law of sines and the law of cosines, probably next week or the week after, what you do with the law of sines and law of cosines, you don't have to do any of this ever again, because you could always use one of those 2 laws on every triangle in the world, not just right triangles. All right? That help any? No?
That did.
All right, give me 1 second to do this.